Imagine a world where robots save lives in situations too dangerous for humans. Advanced robotics is transforming surveillance, search, and rescue missions across the globe. From disaster zones to remote terrains, these intelligent machines locate survivors, gather vital information, and act faster than humans ever could. Equipped with sensors, AI, and mobility systems, they can work in hazardous environments with precision and reliability. Today, we'll explore how these advanced robots are revolutionizing emergency operations, the technology behind them, and the incredible impact on saving lives. If you want to stay updated on cutting-edge robotics, make sure to like, subscribe, and hit the bell icon for the latest updates. 1. What are advanced rescue robots? Advanced rescue robots are intelligent machines designed to assist in dangerous or life-threatening situations. They can be ground-based, aerial, or amphibious, depending on the environment. Equipped with sensors, cameras, and AI, they navigate obstacles and detect survivors. These robots can work in collapsed buildings, flooded areas, or hazardous zones. They reduce the need for human rescuers to risk their lives. Some robots are remotely controlled, while others operate autonomously. Their compact size allows them to access tight spaces. Rescue robots can relay live information to teams on site. Over time, these machines have evolved to become faster, smarter, and more reliable in emergencies. 2. Surveillance applications. Robots are increasingly used for surveillance in dangerous or inaccessible areas. They monitor disaster zones, detect hazards, and provide real-time intelligence. Equipped with thermal cameras, they can locate humans in darkness or smoke. Sensors detect chemicals, radiation, or structural instability. Surveillance robots help first responders plan operations more efficiently. Drones and ground vehicles often work together to cover wide areas. AI algorithms analyze the data to identify risks quickly. Robots reduce human exposure to hazardous conditions. Their continuous monitoring ensures nothing goes unnoticed. 3. Search and rescue operations. Search and rescue robots are critical in locating missing or trapped individuals. In earthquake zones, they navigate rubble to find survivors. Flood rescue robots reach areas where humans or boats cannot go. Equipped with sonar or infrared sensors, they detect heat signatures. Some robots carry supplies, medical kits, or communication devices to stranded victims. They reduce rescue times dramatically, improving survival rates. Teams rely on robot-gathered information to plan safe interventions. Autonomous movement allows them to work continuously without fatigue. Rapid deployment is key during life-threatening emergencies. 4. Types of rescue robots. Rescue robots come in many forms depending on the mission. Wheeled or tracked robots navigate rough terrain easily. Legged robots mimic animal or human movement to climb debris. Aerial drones provide aerial surveillance and delivery of supplies. Amphibious robots operate in water or flooded areas. Some are small enough to enter collapsed buildings or tunnels. Modular designs allow attachment of specialized sensors or tools. Hybrid robots combine multiple capabilities for complex operations. Each type is tailored for specific emergency scenarios. Ongoing research focuses on making them more adaptable and efficient. 5. Navigation and sensors. Advanced robots use multiple sensors for precise navigation. Cameras, LiDAR, sonar, and infrared detect obstacles and humans. AI processes data in real time for autonomous decisions. GPS ensures accurate location tracking in outdoor environments. Sensors measure temperature, gas levels, or structural integrity. Redundant systems ensure continuous operation even if one sensor fails. Robots communicate with control centers or other machines for coordinated action. Real-time analysis helps teams make faster, informed decisions. Advanced navigation ensures robots can reach survivors safely. Reliability and precision are critical in high-risk operations. 6. Disaster response. Robots play a crucial role in responding to natural disasters. They scout dangerous areas before humans enter. Fire, earthquake, and flood zones are monitored for hazards. Robots deliver emergency supplies to inaccessible locations. They assess structural damage and map disaster zones quickly. Real-time information improves decision-making for relief teams. Reducing human risk allows teams to focus on urgent tasks. Robots operate in continuous shifts, enhancing efficiency. Their presence accelerates rescue missions and saves lives. Disaster response has become faster and safer with robotics. 7. Medical and humanitarian assistance. Some robots carry medical supplies to injured or stranded people. Automated delivery systems transport first aid kits, medicines, or communication tools. In remote areas, they provide immediate support while human teams arrive. Robots help in evacuating patients from dangerous environments. AI ensures correct delivery and timing of supplies. They also monitor victims' vital signs in hazardous zones. Robots bridge the gap between victims and rescuers efficiently. Humanitarian missions increasingly rely on robotic support. Advanced robotics stage both time and lives during emergencies. Continuous innovation improves their effectiveness in such tasks. 8. Advantages over human deployment. Robots reduce risk to human rescuers in hazardous zones. They operate continuously without fatigue or stress. AI allows rapid detection and analysis of threats. They can carry heavy loads or equipment over challenging terrain. Advanced sensors detect dangers invisible to humans. Robots reach confined or structurally unstable areas safely. Their speed and precision improve rescue efficiency. Using robots reduces human casualties and improves mission outcomes. They complement human teams, increasing overall operational capacity. Robotics extends the reach and effectiveness of emergency responses. 9. Challenges and limitations. Despite their benefits, rescue robots face limitations. Technical failures or communication loss can hinder missions. Autonomous systems may struggle in complex, unpredictable environments. High development and maintenance costs restrict widespread deployment. Harsh weather or debris can impede mobility or sensor performance. Training personnel to operate robots effectively is essential. Dependence on technology may reduce human skill in some areas. Ongoing research focuses on improving reliability and adaptability. Ethical considerations arise in using AI for life-critical decisions. Awareness of challenges ensures safer and more effective deployment. 10. The future of rescue robotics. The future promises smarter, faster, and more versatile rescue robots. AI advancements will allow fully autonomous operation in extreme conditions. Integration with drones and satellite systems will create coordinated emergency networks. Smaller robots will reach areas humans cannot access. Heavy-duty robots will carry larger payloads and deliver supplies efficiently. Improved energy systems will extend operational time. Collaboration between humans and robots will redefine emergency response. Ethical frameworks will guide safe and responsible use. Rescue robotics is shaping a future where lives are saved faster and safer. In disasters or emergencies, advanced robots are no longer just machines. They are lifesavers. Their intelligence, speed, and reliability make them critical allies for first responders. If you found this video insightful, hit like, subscribe, and turn on notifications for updates on the latest in robotics and technology. Share with friends passionate about innovation, and leave a comment on which robotic feature amazed you most. Stay updated, stay informed, and let's explore the future of robotics together.